Hi everyone, welcome to this video on lesson 12 in the sound and light scheme, which is on the eye. In the previous lesson, we introduced students to lenses, and students saw how different shaped lenses, and at this stage we're just focusing on convex or converging lenses, but they saw how different shaped lenses have different powers, which means they refract light that's incoming more or less. And because of that, they have a different, what we call a different focal length. And it'd be worth starting this lesson before you even look at the eye. Go back to what you were doing in the previous lesson, and just recap on some prerequisite knowledge. So let's say you've got two lenses, and even better than if you've got a diagram like this, if you have two real lenses, question the students which one is going to refract light more. Hopefully they'll be able to recognize that this one will refract light more. You might also ask which one is more powerful, and again hopefully they'd recognize this refracts light more because it's thicker and therefore it's going to be more powerful. And then you could say, well, okay, which one's going to have the greater focal length? Is it going to be this one or this one? And that's where students might get confused, because the relationship between focal length and power is inversely proportional. You don't need to couch it in those terms to year 7, but what they need to recognize is if this is more powerful, it refracts the light more, and therefore it's going to have a shorter focal length. And I can just remind you of the diagrams we had in the last video, or if you've not seen those. So this would be a lens with a short focal length. This would be a very powerful lens, the fat lens, to look at the diagrams that we just had just now. So these would bring light together very close to the lens itself. That's a really powerful lens. Whereas a thinner lens like this one, that's going to have a ray diagram that looks a lot more like that. It's going to bring light to the focal point much further away from the lens. So nothing new there. That's just recapping what students looked at last time after looking at lenses in the lab and drawing diagrams and so on. Now, what you want to do in the next part of the lesson is get students to think about, well, what happens when we see stuff? Because actually, it's just building on this same idea, all to do with refraction. So the first thing you can do is just sketch the eye. And we're going to sketch the eye somewhere over here. We're not going to do a very complicated version of the eye. And again, before you start sketching the eye, it's probably worth getting them to look at each other's eyes and just spot some of the main features that they can see. Things like the iris and the pupil and the fact that there's a kind of shiny but see-through layer at the front, which is the cornea. So you can get them to have a look at that. And then we're going to do a really, really simple sketch here. A really simple sketch. It's going to look a bit like this. So again, this is one of those topics where at GCSE they'll learn a bit more. They'll learn the names of the muscles that make this stuff work and lots of functions of different stuff. Right now, the purpose of this lesson in year 7 in the sound and light scheme is just as a concrete example to help them get their head around this idea of refraction and practice doing ray diagrams and so on. So we don't need to go into loads of detail, and we're going to keep our diagram quite simple. Now, you may want to label this, although actually what you'd rather is that they can remember this. So if you can do it without actually writing in their books what each part is, that's great. I'm going to label it for now. So you can label the optical nerve, which we'll come back to. There's this kind of screen at the back of the eye here like this. So this is really important. This is called the retina. So you're expecting students to just have the basics of the eye by the time they finish this lesson. Now, again, there's lots and lots that we could talk about in the eye. We're not going to talk about all of it. You can say, for one, there's this protective layer around the front, like this. So this would be the cornea. And then you can say, again, you don't need to go into loads of detail about the iris, which is the coloured bit of the eye. But you could add a label here, although I don't think that comes up in the practice. But what is important is that that creates a hole, which changes size. Again, they'll look at that in more detail when they get into kind of rods and cones and all of that business at GCSE. For now, we can just say, well, that hole is the black bit, that you can see in your eye. Remember, at year 7, the main thing is that they're just starting to see how the things that they can see in real life in the lab when they look at each other's eyes, how we kind of organize those observations that they can make in science. So again, just having some names is great at this stage. But then the main thing for today's lesson, and again, we don't need to do loads and loads about this, so we don't need to really worry too much. But the main thing in today's lesson is that they have an idea of the lens. Now, I'm not actually going to draw the lens yet. I'm going to come back to that. But the lens is going to go in here, and we'll make sure that we label it. So you can think about how exactly you want to do this with students. But we're going to draw 2 diagrams in this case. So the first one we're going to do, and this is just building on the prior knowledge. Actually, the first one I'm going to do is a distant object. So let's imagine a distant object. Let's imagine a person standing a long way away. So we can imagine a person standing a long way away. Now, the thing that students need to recognize is that if a person is standing a long way away, actually, there would be a lot smaller than that to the person. And essentially what happens is the light coming from that person is going to appear to the eye to be all arriving almost parallel to the normal. So you're going to have a situation a bit like we had last time, where light is arriving parallel to the normal. And what we want, and again, it gets a bit more complicated than this, but for now it's fine to just say to students, what we want to get a really clear image of this person who's a long way away is for all of the light to focus at one point. And again, you can build on that prior knowledge from last time. What do we call that? Well, we call that the focal point. So we want the focal point to be all the way over here, like this. So what you can tell students is that your lens, when you're viewing a distant object like this, your lens has quite a thin shape like that. And what that does is it means that the focal point where all of those rays of light focus is exactly on the retina. So I can draw something like this, exactly on the retina. And again, if you wanted to label this, you could, in terms of thin lens, long focal point, focused on the retina, whatever. I'm just going to leave it and talk through that with students qualitatively. What I want by the end of this lesson is that they can write about this. So that's my first image. And again, the main point here is distant object, thin lens, focused on the retina, as follows. Now let's imagine we're looking at something much closer. Let's imagine the example I saw, one example I've seen is a cup of coffee or something like that. So let's imagine there's a cup of coffee which is right up close. So I'm going to draw a cup of coffee like this. You can do whatever you want, any object that's nearby. I'm going to draw my same sort of diagram here. Eye's got a bit funny there. It's got a bit large. Let's, somehow I've developed a bulge in my eye in between the 2 examples. Anyway, hopefully your diagrams will be better than mine, and students will get the idea. So I can draw the same things on here. I can draw the retina at the back here. This is the optical nerve, or the optic nerve. I can draw the iris and the pupil. I'm not going to label all of it this time because I labelled it in the previous example. And looking like that. Now what you want students to recognise here is that we've got a slightly different scenario to what we had before. If your object is a lot closer than it was before, the light rays are not going to be coming in parallel. The light rays are going to be coming in from a point. So they're going to be coming in a bit like this. And I'm going to try and sketch this. Yeah, I might have gone wrong already. Here we go. Going to be coming in from a point that looks like this. Now what you want to elicit from students is the idea that, okay, if they're parallel, they all come together at the focal point, so we need to make sure that the focal length is that distance there, and we need quite a thin lens to do that. If they're coming from over here though, are we going to have to refract them more or less to get them to focus on here? And what you want them to recognize is that if they're coming from a point that's closer because you're viewing a nearby object, the refraction that's going to need to take place here is going to need to be more. Light is going to have to change direction more in order to stay focused on here. And then you can say, okay, if light needs to be refracted more, does the lens need to be more or less powerful? Well, it needs to be more powerful. So does the lens need to be fatter, or should it be even thinner than it was in this example? And what you want to elicit from students is that in order to focus the light coming from a nearby object exactly on the retina as we did before, because we need more refraction, we need a more powerful lens, the lens changes shape, it becomes thicker. So what I'm going to do is really exaggerate this, and now our lens becomes thicker. And again, they might ask questions, well, how does that happen? It happens because you've got these muscles up here which can sort of stretch and squash the lens essentially to make it even fatter. But what you want to show then to students is, okay, if we need to refract it more, what that means is, it goes something like this. You get even more refraction because your lens is fatter, and therefore you can still manage to focus it on the retina and get a clear image. So this is the difference between how the eye views distant objects and nearby objects. And everything that you'll see in the deliberate practice task at the end of this lesson is really just around this. Firstly, there's labeling these different parts, but that most students should find relatively straightforward, and you can check that they're okay with that. What's more difficult is making that link between how far away the object is and the shape of the lens, and therefore where the light ends up being refracted to. So that is the first lesson on the eye. In the next couple of lessons, we will look at why we get problems with the eyes, so why some people are short-sighted, why people are long-sighted, and then how we can use lenses to correct that. But again, the main point to emphasize to students is we keep coming back to these ideas about how light behaves and how we can represent that using ray diagrams.